Hello friends and welcome back to my channel. Today we will begin our journey on the road to relativity. In today's episode, I have divided into two sections. The first section, Scientific Theories 1, talks about theories in the pre-relativity era. The other section, Scientific Theories 2, talks about theories that laid the foundation for relativity. So we will start with the first section, Scientific Theories 1, or the theories in the pre-relativity era. Assume that you have to travel from one place to another and this place is far off. Say you want to travel from Mumbai to Delhi, or say Mumbai to Bangalore, Kolkata to Delhi. You would require a mode of transport or a medium to travel. So some of you would prefer flights, the others would prefer going by road, by cars. The bikers would love biking on these roads. But the essence is you would require a medium to travel. This was the base assumption of theories in the pre-relativity era. The assumption was that anything which moved from one place to another required a medium to travel, including sound and light. So sound would require air as the medium, and light would require a medium which was known as ether. Commonly known as luminiferous ether. It was assumed that ether filled the entire universe and all planets and stars were moving in this medium. Ether was invisible in nature and also had elastic properties. The issue was that if there is something which you cannot feel or you cannot see, then how do you assume that it exists? To understand this, let's go back in history and we look at Newton's theory. Newton had proposed the particle nature of light, that light is made up of particles and therefore light experiences all kinds of forces including gravity. However, his theory was challenged later on by many scientists, including Thomas Young, who proved through his experiment of double slit, which is commonly known as double slit experiment, that light was a wave. And if light is a wave, the wave is a disturbance, and any disturbance can only travel in a medium. A disturbance always requires a medium to travel, and therefore if light is a wave and wave is a disturbance, then it requires a medium. So the story of ether got reinforced with this experiment, and everybody started believing that ether existed, even though they could not feel it or could not see it. So it was assumed that ether was absolute and light moved with a certain velocity with respect to ether. So if I depict ether by these small lines filling up the entire universe, as you all can see, and if light is traveling in ether, it is traveling with a velocity c with respect to ether. Now assume there is a spaceship which is also traveling in ether with an observer in that, and this spaceship is moving in the same direction as light with a velocity v. Then what would this observer perceive the speed of light to be? It is pretty obvious, both of them are moving in the same direction. It will be c minus v. Now this observer decides that he is going to turn around his spaceship. So now this observer turns around his spaceship and starts moving in a direction with the same velocity v, but in the opposite direction. Now what will this observer perceive the speed of light to be? Now it will be c plus v. From these two examples, it seemed that the perceived speed of light depended on person to person. That depended on the direction he or she was traveling and the magnitude of the speed. Does it mean that speed of light was personal in nature? Because ultimately it depended on which direction you were traveling and at what speed you were traveling. Sounds pretty strange. Two scientists came up. One was known as Albert Michelson and the other was Edward Morley. They wanted to test this theory and so they decided to design an experiment. For this experiment, they used Earth as the test piece. So the question was why they used Earth as the test piece. They used Earth as the test piece because the entire universe is filled with ether. And Earth also moves in ether. And if Earth moves in ether, then just like the spaceship, it will also have its moments of c minus v and c plus v. And it could be easily captured. So how did they conduct the experiment and what was the concept of Michelson-Morley experiment? Let's discuss the same. So let us understand the Michelson-Morley experiment. So what we see is this is the sun and we have the earth. If I make this circle, this is the earth which is orbiting around the sun. Say this earth is orbiting around the sun with the velocity v. So I make a velocity v here like this. What Michelson-Morley proposed was that if we can take a beam of light and split that beam of light in such a way that one beam is in the direction of motion of the earth and the other beam is in the direction perpendicular to the motion of the earth, then what we should see is that the beam in the direction of the motion of the earth should undergo the ethereal effect. Remember we talked about that c minus v, c plus v phenomena. So this particular beam will go through the ethereal effect, whereas the beam perpendicular to the motion of the earth will remain unaffected and it will move relative to ether at a velocity c. This was the concept that they were trying to test. So for this, they designed a setup which is shown over here. Now in this setup, what they proposed was they put up a half silvered mirror and a light source. Now the half silver mirror they had put had the purpose of reflecting one beam perpendicular to the motion of the earth. You see, this is the motion of the earth, v, which is showing here. This is showing in this direction. It's the same v over here. So this half silver mirror would split the beam in the perpendicular direction and the other half of the beam, it would send it in the direction of the motion of the earth. Now, these are two reflecting mirrors. So this distance is d and this distance is also assumed to be the same d. Though in the diagram it may not be looking to be the same, but you assume the two distances to be d. So what will happen? The the ray of light moving, or the beam of light in the direction of the earth, will undergo the ethereal effect. So if this beam is split up and one goes in the direction of motion of the earth, then it will experience the ethereal effect and the ethereal effect of C minus V. This beam will experience an ethereal effect of C minus V as it is going towards this reflecting mirror. When it comes back, this will experience an ethereal effect of C plus V. According to Michelson-Morley, this should happen. Now, assume that the earth was stationary. If earth was stationary in ether, then the beam perpendicular to the rotation of earth would move with the velocity c, and earth was stationary, so v will be 0. So this beam will also experience the velocity c. This is c and this is c. So the time taken by this beam to come back here after going and then coming back here, and the time taken by this beam going and reflecting back here would be the same. It will take the same time. If this beam takes time t, this will also take time t. And if they take the same time t, then what Michelson-Morley said, that if I bring this beam to this receiver, which is a telescope here, right, then they will give a constructive interference, because there is no time difference between the two beams. But this was with the assumption that the earth is stationary. If the earth is stationary, only then these two times will be equal. But Michelson-Morley said that this would not happen. Why? Because the earth is moving and the ethereal effect is in play. So they expected that there would be a difference in time between this beam and this beam. So what they said was that if this beam goes and comes back, and if this beam goes and come back, this beam could take a time t1, and this beam could take a time t2, where t1 will not be equal to t2. And so they were expecting a time difference between these two beams. However, when they actually conducted the experiment, they found that these two beams, the T1 and T2, came out to be the same. There was no time difference. They conducted this experiment multiple times, also at multiple positions of the earth, because they said that it might be that in one position of the earth we are getting this result. So they conducted this experiment at a position of the earth, say here, if this is A, this is B, this is C, this is D. At various positions of the earth they conducted this experiment, but they found the same result. The result was that the ethereal effect was absent. The two beams took the same time. T1 equal to T2 equal to some time T. They took the same time to come back. So they were very surprised. They were surprised by the result of the experiment, but they did not expect this to happen. But ultimately, this experiment proved that there is no ethereal effect that formed the basis of so many scientific theories. Ether, the existence of ether was being questioned. But the main question was that if ether did not exist, and the ethereal effect, and therefore the ethereal effect was also absent, then how did light travel? Because as discussed in the earlier segment that light is a wave and wave is a disturbance. And disturbance requires a medium to travel. And right now this experiment proves that there is no medium as such like ether. So how did light move? The answer to this question, which was left out, was in Maxwell's equations or Maxwell's theory. So we will try to understand what Maxwell's theory was. So let us understand Maxwell's theory on electromagnetic waves. Now what Maxwell said was that an electromagnetic wave has an electrical field which is shown by this red curve. So if you see, this is the electrical field axis, this is the magnetic field axis, and this is the x-axis which is shown by this direction. So what he said was a varying electrical field, which means you see the electrical field moving this way, it's a varying electrical field, will produce a magnetic field in a direction perpendicular to the electric field, like this. A varying electrical field produces a magnetic field perpendicular to the direction of the electrical field. And then what happens after that? What happens after that is a similar situation. This magnetic field which is produced is also varying in nature. You see, this is a varying magnetic field, right? This varying magnetic field also produces back the electrical field. You see, like this. So a varying electrical field produces a magnetic field, and a varying magnetic field again produces an electrical field, and this varying electrical field will again produce a varying magnetic field, like this. And this process goes on and on and on. So what he said was that an electrical field is created, and this varying electrical field produces a magnetic field. It is in the perpendicular direction, and this magnetic field creates another electrical field, and this varying electrical field creates another magnetic field, and so it moves like this. This is how an electromagnetic wave travels, and what is commonly known as the self-propagating nature of electromagnetic waves. He further concluded that the speed of the electromagnetic waves are very close to the speed of light. And if that is the case, then light is also an electromagnetic wave. And if light is also an electromagnetic wave, it will have a varying electrical field, which will produce a varying magnetic field, again a varying electrical field and varying magnetic field, and so it will also be self-propagating in nature. This gave us the final answer that light does not require any medium to travel. It propagates by itself. It propagates on its own. And this finding changed the entire concept in science. So Michelson-Morley experiment and Maxwell's theory and his equations brought forth the following conclusions. First, there is no such thing as ether, which was assumed to be present in the entire universe. The second conclusion was that light does not require any medium to travel. It is self-propagating in nature. And the last conclusion was that no matter how you travel and at what speed you travel, in what direction you travel, the speed of light will come out to be the same. it is constant, and it is 3 into 10 to the power of 8 meters per second. These were some very important conclusions which came out through these experiments and through these theories, and it changed the science altogether. Albert Einstein observed the findings or the conclusions from the Michelson-Morley experiment as well as Maxwell's theories. And he was convinced that the speed of light would be constant. So he went back to the drawing board and started looking at a very simple equation. And the equation was speed is equal to distance upon time, which can also be written as space upon time. And so if speed is constant, as already stated by the experiment and the theories, then speed is constant, then there is something happening in the dimension of space or the dimension of time, and there is a possibility that there is a relation between space and time. There is an interplay. So he wanted to figure this thing out, and that led to his theory on special relativity. So friends, in the next episode, we will try to understand Einstein's thinking on these lines and his thought experiments. We will also look at some very important conclusions from other scientists such as Lorentz, Poincare, and Fitzgerald. So friends, this is all for the day. But before I conclude or before we end this session, I wanted to make a point. I got a feedback from my previous episode, which was an introductory episode, that I have to make my videos a little simpler, so for everybody to understand. So somebody who's not from a science background can also understand the same. And in line with this, what I tried to do in this first episode was to just explain the concepts without going into a lot of details with regard to the experiments or the equations behind the theories. The idea is to make it much more simpler for everybody to understand. If you think that it has to be made much simpler and some things have to be done in this regard, then please do put your comments in this comment box. If I have to include something which you want to know, please also state the same. And I want everybody to understand the concept, so it will be easy for us to move through this journey on relativity. And I look forward to the next episode. Goodbye for now.